Hello all, welcome to my tutorial how to use my software WinWave Optics Lab. This is to process this kind of videos of surface waves captured by regular cameras in order to compute its spectrum. Here I show you the version of the software which is this tutorial is valid for. And first, I close it to run it again for you. And here is the project directory, and here is the command window. I use Linux Mint Debian Edition to run this test. This is the starting file. You can't see my mouse pointer, unfortunately, but I will select it for you. Just run it with Python. To start with the source file, quick start, just press this button and find your test file. Some tests are included. You may leave all parameters default. The most significant parameter is this one. This is going to be the Fourier length in frames over the all further processing. And what is happening under the hood? We were running FFmpeg software to split video into image files, and then my Python code just opens this image file. Thanks to that, we can process just any format of video because FFmpeg is very, very universal software. This pen is for free zoom mode. When it's on, you can use the mouse pointer to move and mouse wheel to zoom video. Okay. In this mode, you can watch your video as a slideshow. You see. Next, we have to set up. Camera. What you can see on the right, this is. Maybe I have to make this frame smaller. What you can see on the left in any panel is the JSON code, and this JSON code is saved in project file and loaded again. You can edit it manually. At this time, we have a limited number of pre-configured cameras, sorry to say, and you have to, for your applications, you have to add your camera and calibrate it in some external software, sorry to say, but that is okay. Well, what we have to know to process video, we have to know what the camera was, what the camera height was. I guess it's like 20, and what was the angle between the camera and the vertical line. For that experiment, I recall it to be 70 degrees. Uh, After that is done, we go to the next slide, and we select processing area, and the software draws like a trapezoid due to perspective. Actually, if the camera settings is right, then this skew figure is going to be rectangle after the projection. Okay, and after this step is done, we finally can press process. When waiting this process to finish, I going to tell you that the test projects are located in my repo in this folder, and the data file named videos, they are stored in an external repo, and they're going to be a link how to download it. Well, now finished. Okay. The right hand side image is our rectangular after perspective correction. You can see the waves moving on the right when they are moving on the left. Next slide is for spectrum. And I'm going to press the first button. Well, now a short theory break. What oceanographers expect from my software, or just from all video recordings of surface waves? Oceanographers want to know so-called three-dimensional spectrum. It is Kx, Ky, and frequency. Recall that K is the wave number, it is the inverse wavelength, and the frequency is inverse period of waves. Okay, so it's a cube of data. On input, we have three-dimensional array of pixels, which is the video, which is height, width, and time. And on the output, we have wave number, and frequency. Well, but we can't draw three-dimensional fields on our screen, so we make we're going to make cross sections of them. The first kind of cross section is a cross section at a fixed frequency. The second panel is just for adjusting how it is plotted. Each time I press this button plot to replot, okay? And when I use the theory switch, you can see you can see a circle. You see the surface waves are expected to come with the dispersion relation. So at fixed frequency, waves travel at a fixed speed, and they have a fixed wavelength. So, and which wavelength we expect, which inverse wavelength we expect to see on this frequency, I plot with this circle. You see there is some problem with calibration occurred. Probably I entered the wrong height of the camera relative to the surface, so our spectrum missed a bit from the theory circle, but that's okay. And I want to show you what is happening under the hood each time when I press the plot button. Actually, I call GNU plot to make this image, and I download this GNU plot. I have some, if you know GNU plot scripting language, you can do many things for editing this plot. Actually, there is a place. First of all, there is a place where to write this something to add to the script. Okay, and there is a button to launch this GNU plot interactively. Just type exit to exit this. So the next kind of cross section is this one, frequency wave number. On this kind of plot, we can see exactly if the theory is matched or not. Okay. Some problem with the limits are not the problem. Okay. So this bright area is what the dispersion relation should be. Okay. So and finally, we come to the frequency plot. Back to theory. Now I'm going to tell you that this video record of surface waves, this is not a direct way to measure surface waves. We can make mistakes due to right and height relation. It's not really straightforward, but there are ways, there are methods how we can measure frequency spectrum in a very reliable way. So we can get only frequency, but very reliable. So the idea of this program is that we have this frequency spectrum of the video, and we will compare it with some reference value. So how we do it in this software? Sorry to say, that's not easy. First, I have to save my spectrum. Oh. It calls for a while. Oh, I have forgotten to show you. You see, can you see these ticks in the wave? This tick provided us the frequency spectrum. This one. Is just this is just a table of frequency and spectrum level in dB for that specific experiment. I copy it to my spectrum folder and call it echelon. Sorry, this is just transliteration from English. Going back to spectrum, you see the upper plot is from video, the lower plot is from echelon. We have this kind of calibration panel, and we can the main thing that we have to adjust is the difference between this peak level. We can see that it is around 55 dB. Minus 55 dB. No, they are pretty well matched. Adjusting other values, we can get the best match. Just read just study the reference papers for more smart understanding of what is happening now. And after this calibration is done, all other plots include all other cross sections of three-dimensional plot. It is in true values, and you can see that this kind of plot have become much more clearer. You see, compare this one to that one. So this is all functions that are working fine up to now. There are some functions under construction, like filter, plus and moving average. Just don't use them right now. So if you have any questions, please email me. Thank you for listening, and goodbye.